chapter, we're going to be studying the limits to measurement. In this lesson, we're going to look at adding and subtracting values, but including the uncertainty.
Okay, hi everybody. So in this lesson, we're going to look at adding and subtracting values with uncertainty. Okay, so the idea being that maybe you're building something, and you've measured, I don't know, a piece of wood, or you've measured something, and there's going to be a little bit of uncertainty with it. And then when you combine it with another piece that you've measured, there's going to be a little uncertainty there. Okay, and so whether you're adding two pieces of wood together, or let's say you've got a piece of wood that you've measured, and then you're cutting a piece away from it, those measurements there all bring with them a little bit of uncertainty. And it doesn't matter whether you're putting them together or cutting a piece away from another one, the uncertainty or the little bit of error there gets bigger. And so what I mean by that is, let's take a look at this. I grabbed a ruler here that's got a very specific kind of a scale on it. I'm going to just draw a line here, okay, so you can see that. I'm going to start here, and let's say I go to there. Let's zoom in on that. Okay, so now my ruler here works to tenths of an inch. Okay, so I've marked that out here. It's tenths of an inch. That's as far as it goes here. Now take a look at this line here. Lining it up with the zero here, it's 1 inch, and then 1, 2, 3, 4. It's a little over, okay, it's a little bit over 4/10 of an inch. Okay, so right now, this looks like 1.4 inches, but it is a little bit more than that. If I line that back up again, it is just a hair more than that. Now, what happens here though, because it's not quite at the halfway mark there between 0.4 and 0.5, I'm rounding down. But there's a little bit of an error there. That's what we're talking about here. Now, what's the largest that error can be, okay, before it's so big that, no, I just go to a different measurement? Well, it's 0.5, sorry, each one of these things is a tenth of an inch, so it's going to be half of that. The precision here is going to be a tenth of an inch, so my uncertainty is going to be half of that. Okay, so a half of a tenth here, and as soon as that line segment is larger than a half, and what I'll do is I'll just slide this back to give you an idea here. As soon as it's a little bit beyond the halfway mark, then I'm going to round it up here. But there's this error, this little bit of an error there that I have to consider in this measurement here. And every time I make a measurement, there's going to be this little bit of an error, and they get larger. Whether or not you're combining your calculations or you're doing subtraction, that little error gets bigger and bigger. So take a look at this example here real quick. Suppose you got suppose two shelves, what? That doesn't make any sense at all. So you got two shelves, and they're just pieces of wood there. There's a missing word there. And they were cut so that their respective lengths are 2 feet plus or minus 1 inch, so there's a bit of uncertainty there, and 4 feet plus or minus 1 inch. The maximum length of each piece of wood is going to be 2 feet 1 inch. So I'm going to look at the maximum value and the minimum values here. So when you combine their maximum values, that could be 6 feet 2 inches. On the other hand, their minimum lengths could be 1 foot 11 inches and 3 feet 11 inches if you subtract 1 inch off of both of those. So their minimum combined length would be 5 feet 10 inches if you add those together. Okay? Now, and I'm hoping you remember looking at adding and subtracting imperial measurements from an earlier course here. Now, that all aside there, just to make this easy here, what we're looking at here is we've got 2 feet plus or minus 1 inch. And we're going to combine that with 4 feet plus or minus 1 inch. So I don't want there to be any confusion about this. Don't worry about the plus or minus right off the bat here. When I'm putting those together, okay, 2 feet and 4 feet, that's 6 feet. Okay, I'm not doing any kind of weird math here. That's just going to be 6 feet. But I've got this plus or minus, this uncertainty of 1 inch, and I've got this uncertainty here of an inch as well here. I can put those together to get an uncertainty of 2 inches altogether. That's what you got to do. Whether you understood this maximum or minimum part there, That's what that I got to do here. So my final shelf here, when I put those together, that could be 6 feet and 2 inches, or it could be 6 feet less 2 inches, which would be like 5 feet 10 inches. That works even if let's say we started with a board that was 4 feet 1 inch, 4 feet plus or minus 1 inch, and let's say I'm going to cut away from it a board that's 2 feet plus or minus 1 inch. Well, even if I'm doing subtraction here, now watch this. 4 feet, don't even worry about the uncertainty here. 4 feet minus 2 feet is going to be 2 feet. That's what it is. But when we take a look at the uncertainty here, this was plus or minus 1 inch. This is plus or minus 1 inch. There's a little bit of an error with each calculation. The error will always get larger. So this is still going to be 2 feet plus or minus 2 inches. You're still going to add those together. Regardless of whether you're combining the overall measurements or subtracting the overall measurements, the uncertainty always just gets added together. This is probably in this particular chapter, this is probably one of the more difficult things just to get your head wrapped around it. That's what is happening every time. Whether you're adding or subtracting, the uncertainties get added together. Okay, now let's take a look at some examples. Okay, so this example, we read that Savannah is making a piece of jewelry from two pieces of different metals. Okay, the first weighs 9.22 grams, and the second weighs 5.73 grams. What are the precision and uncertainty for each weight of material there? Well, notice that in both cases here, here's the decimal, and I go 2 places over. That's the last place here. Over here, here's the decimal, and I go 2 places over. The precision, okay, the precision is always going to be the position of that last number in terms of the decimal. So my precision is going to be 0.01. Now, I have to assume, it's based on the information I'm given here, I have to assume that whatever weight scale I'm using, that if I'm getting measurements like this, that it must be good to the nearest hundredth of a gram. Okay? That has to be my assumption here. Unless I'm given some other information, unless I'm told that like it goes up by like 3s or 4s, hundredths of a gram. I'm not told that. So I simply find the position of the last digit in the number, and then that's going to be my precision, which means my uncertainty is going to be half of that, so it would be plus or minus 0.005 grams. Okay, so I can give measurements to the nearest hundredth, which means my uncertainty, I have to round over, okay, plus or minus 5 thousandths. Okay, half of that right there. Now, if you add the 2 weights together, so it's going to be 9.22 grams plus or minus 0.005 grams. And we're going to add that to 5.73 grams plus or minus 0.005 grams. The answer is going to be, well, first of all, just add the weights together. Don't worry about the rest of that. Just add the weights together. 9.22 and 5.73 is going to be 14.95 grams plus or minus. Okay, now this has a little bit of an error to it, a little bit of uncertainty. This has a little bit of uncertainty. I combine those together, so it's going to be plus or minus 0.01 grams. Now, just to take a moment to explain what that means. What does that mean? Well, it means after I've put them together, everybody, the absolute minimum mass that these two together would be the 14.95 grams minus that hundredth of a gram. So it would be 14.94 grams. And the absolute maximum mass that we could get here would be this number here plus this one right here. So 14.96 grams. So I know okay, I know that when I put those two, or when Savannah put these two pieces of metal together, the resulting mass is going to be somewhere between those two values. Okay, we know that. Okay, and I am 100% sure that's the way that's got to be. Okay, so in this question we read that Jacob is a chemist. He's preparing a solution, or he's preparing, it should be solutions with a graduated cylinder marked off in 2 milliliter units. Okay, I'm telling you that the smallest demarcation that's on that cylinder is 2 millimeters. That is my precision. In the previous question, I wasn't told what that was. I had to kind of guess at what that was based on the numbers that I was given, but here I'm told. He has 55 milliliters of a solution and needs to pour 26 milliliters of it into a different mixture. Okay, what are the measured volumes of the original solution? Well, it was going to be 55 milliliters plus or minus 2 milliliters. Oh, sorry. It's plus or minus the uncertainty, and that is not the uncertainty. The uncertainty here is 1 milliliter. That's my mistake. That's right. I should have gone over here and actually done this. This means that the uncertainty is going to be 1 milliliter. So the measured volumes of the original solution, 55 milliliters plus or minus 1 milliliter. And then the other one here, we're going to pour that out. Okay, that's going to be 26 milliliters plus or minus 1 milliliter. So what's the volume with uncertainty of the fluid remaining in the cylinder? Okay, well, that was going to be 55 milliliters plus or minus that 1 milliliter, and we're going to subtract from that 26 milliliters plus or minus 1 milliliter. So remember, at first, we just deal with this right here. Okay, and so 55 minus 26 is going to be 29. Okay, plus or minus. Now I know we poured off that 26 milliliters, but because there was a little bit of uncertainty here and a little bit of uncertainty here, that ends up combining to become 2 milliliters. So it's 29 milliliters plus or minus 2 milliliters. What does this mean? Well, that means that the minimum volume that could be left in that cylinder after I poured that off, the minimum volume could be 27 milliliters. Whereas the maximum volume that might be left in here, if I add that on, could be 31 milliliters. But I am 100% positive that the actual volume is going to be somewhere in between there. See, there's always going to be this little bit of uncertainty, or you're not sure about the measurement. But then with that being said, then there are certain things that I can be sure of. These are the limits to where that error could lead us.